Okay, so now we're going to talk about basic Arduino sketches or projects. So this is part 2B of digital design embedded software. So we need to start learning the basics. We need to use the most frequently used functions in the Arduino library. Pay close attention to these very simple programs. So blink and LED, which we've already touched on. Digital reading and monitoring with the serial port. Reading analog sensors and monitoring with the serial port. Reading analog pins and converting the input value to a voltage range. Fade and LED with pulse width modulation using analog write. Now, these are all tutorials that you can find on the Arduino, and you can build these up in your hardware, and also Tinkercad that I'm going to show you. So blinking an LED is extremely simple, doesn't seem fundamental, but it involves key functions. Setting the pin. Is it input, output, or input pull-up? Digital write allows us to control the voltage of an individual Arduino pin. Delay stops the program for a specified amount of time whilst maintaining the voltage of the pins at the stop. An integer data type, int, holds whole numbers and is preferred when dealing with smaller numbers because of memory considerations on the embedded system. The first program any person usually writes when learning a new programming language is usually known as Hello World. Its only function is to display the words Hello World on the computer monitor. Whereas when learning an Arduino microcontroller programming, the equivalent of Hello World is to write the program that blinks an LED. It's known as blink. So connect the circuits as shown. So the resistor is connected to the anode and the cathode is connected to ground. This image was created using a software called Fritzing, and you can use this free of charge. It's open source for your circuit diagrams, or alternatively you can use Tinkercad. So here we use comments to describe the code. So blink turns on an LED for a second and then off for 1 second repeatedly over and over again. Pin 13 has already got an LED connected on most Arduino boards. We need to give it a name. So we've called it LED. It's an integer value, it's 13, and it's called LED. So first of all, we need to set it to pin mode LED output. That loop runs once at the beginning of the program. And then we move on to the void loop. So we want to light up the LED, and this requires the voltage to be applied to pin 13. Therefore, we need the mode of the pin 13 to be output, which we just did. Setting the mode of the pin to output doesn't actually give it a voltage. It just enables the pin to be supplied with a voltage once the program tells it to. So we do this in the void loop function. So loop is the main function of your Arduino sketch. Void loop. Now void because there is no variables being returned and we're not passing any variables to it. So it's just a round open and close brackets. The braces here, the curly brackets, show the start and the end of the function. So digital write, so write high to pin 13, because pin 13 is LED pin. Turn the LED on high is the voltage level. Wait for 1 second. So a delay gives us, a delay is in milliseconds. So 1000 milliseconds is 1 second. digital write LED low, so take the voltage to 0 volts. Here it would have been 5 volts. And again, wait for 1 second and then go around the loop over and over again. And that's the first program. So void loop runs forever, infinitely. The two functions, digital write and delay. Digital write is used to apply either the 5 volts or the low 0 volts to the particular pin, in our case pin 13. By applying the 5 volts to the pin, it's connected through an LED to ground and the LED will light up. 0 volts switches the LED off. So this is the same program at the bottom here. So change the value of delay functions. What would happen? Change the number of the LED variable to 12 and move the long leg of your LED to pin 12 and see what happens. Here are a list of functions to find out about. So if you go to the Arduino homepage and find information about you can find information about any function. So pin mode, digital write and delay. So here's the next example. Digital reading and monitoring with the serial port. So these are the functions that we are going to use in this second program. Serial.begin. So serial means, as I mentioned in the first part, is that the serial, that is a library. So the library contains sub-functions within that library. So the begin function belongs to the serial library. So anything with a dot and then another name, then the library that it belongs to appears first. So serial.begin starts communication between the Arduino and your computer because it's connected with a USB lead. Digital read allows you to measure the state, either high or low, of a digital pin. High equals 1 and low equals 0 in programming terms, but in voltage, high would be 5 volts and low would be 0 volts. But in the program, it would be 1 and 0. Serial.println. So send data, whichever is between the brackets, to the serial monitor, also up to the computer, and show this on the serial monitor. So send information to the serial port, which can be monitored through Arduino IDE. You can create a textual message to tell you every time a button has been pressed, or display the value of the sensor readings. Now, the serial monitor is very good for debugging purposes. So when you're making modifications to your program, then you may want to know what's happening. So we use the serial monitor to view what the variables of values are and whether they're doing the right thing. So whether the functionality of the program is correct or not. In this exercise, we will answer the following questions. First of all, is a button being pressed? Has a switch been turned on? Or what is the on-off sensor status? So these are the components that are required. So a push button, which is pushed on and then it's let go afterwards. So it never stays in the down position. Jumper wires and 10K resistor. So the circuit is set up as shown. So we have the one side of the push button is connected to pin 2 of your Arduino. Then with a 10 kilo ohm resistor, which is connected to ground, that side there is connected to ground. And then the other side of the switch is connected to 5 volts. So this push button here, this pin and this pin is isolated from each other. So we have actually got 2 separate connectors here. Because I've put it over the middle of this breadboard, then we could have 2 separate switches acting at the same time. So here's the example. So I've created the example without the breadboard. So essentially, the code is not very long. So we're saying integer button state equals 0. Void setup. So pin mode 2. So button 2 is input. So when this switch is pressed, switch will be closed. By the way, you can rotate these components. So if don't want to do it on this one, but if I just remove the code, and if the resistor, if you're not happy with it in that position, you can rotate it. So here we've got pin mode 2 as input. So whenever that goes to high, then there is a current going to be flowing. So whenever that push button is switched. Serial begin, so communicate with a serial monitor here, or your computer, but we will see it here too, because this will be communicating from the Arduino up through the wire from the actual hardware. So in this initial loop, in the void loop now, in between the 2 curly braces that we have here, we will read the input from the pin. So button state equals digital read, pin 2. So pin 2, is it on or is it off? Is it 1 or is it 0? Serial print, button state, delay 10 milliseconds. So it's off, it's off, it's off. I press it and it's on. Off, on. Okay. So here's the whole program within PowerPoint here. exactly the same program that we just explained. So again, this explains the program again. So I mentioned about the serial library helping to establish communication between the PC and the Arduino board. Involves sending and receiving data. It can flow both ways. So from the computer, even from a Raspberry Pi, a different type. To establish the communication in the first place, you need to use the begin function from the serial library. This number is the baud rate, so it's how fast the data can be transmitted. So in a further class or tutorial or lab work, when we communicate between one microcontroller and another, you'll find that this standard 9600 baud is too fast for the communications that we're going to do. So the function takes one argument, the number, the baud rate. So it's the rate at which data can flow between the PC and the Arduino board. For most Arduino sketches, the baud rate of 9600 baud is usually used. So this just sets that this is set to input. We've declared our variables here. We've done our setup. Then declare an integer and name button state. So it's called button state. So digital read pin 2, that means. Then serial print line button state. So you don't need any inverted commas or any ands like you do in C. It's just the variable name. Nice and simple. So int button state digital read push button is simply we declare a variable as an integer. So the returning variable from this function is an int. It's being named button state, so the state of a button. It's very important how you name your variables, because later on when you come to debug your sketches and codes, then it's quite helpful if it's descriptive. And this usually we use a lowercase to start with, and then for the second word to have a higher uppercase character. The value 1 or 0 will be saved in the variable button state. So that is what this will do. Equals, we set it equal to the function digital read. So digital read is a function, will return the value 1 or 0 depending on whether the button is being pressed or not. So push button, which was the variable stored the number 2, which is pin 2 on the Arduino. So the serial print line then function returns the value of the assigned argument. It reports this to the serial monitor window on the IDE, which is what I just said. Wait for a delay and then repeat. I opened up the serial monitor port in Arduino. However, in IDE it will be slightly different. So if you open up the serial monitor, all you will have to do is to click Tools, Serial Monitor, or Shift Control M. One way to retrieve the data on an Arduino board. Keep in mind that unplugging the USB from the Arduino, and when batteries are used to power it, the serial print line function won't work because it's not attached. But while you are creating the circuit and the sketch, there is no better way to troubleshoot than using print line and print functions from the serial library. Afterwards, you can always comment it out by doing 2 forward slashes to comment out a line, or a forward slash and a star, and a star and a forward slash to comment out multiple lines. So this time, if we change the function serial print line or println ln to serial print, what happens to the output in the serial monitor window? Can you tell the difference between the two functions? There is a difference. So change the pin that you are reading to, say to pin 3. Make the circuit changes and change the sketch. These are your exercises to try and do. Functions to find out more information about are the following: int, pin mode, digital write and delay. So the next example is going to be reading analog sensors and monitoring with the serial port. So we're going to look at the analog read function, and this will measure the voltage at the analog pins and return a value between 0 and 1023. Why 0 and 1023? Well, it is 1024 combinations. So it is 2 to the 8. There are 6 analog pins in total on the Arduino Uno. These pins have access to the analog to digital converter. I've got my example in Tinkercad here. So we're using analog input 0. So we've got 3 inputs on this potentiometer. One input goes to the 5 volts. One input to the potentiometer goes to ground, and the middle terminal, or the wiper, which is the part is a variable resistor, goes to the analog input terminal. This is a 250 kilo ohm potentiometer. Then I'm monitoring the ground and the output on pin 13. We should see the LED, the built-in LED, flashing on and off at the same time, and the output here. I'm not going to run the circuit yet. I'm going to go back to our PowerPoint. So what does the circuit do? We've seen the circuit. What does the program do? So let's take a look at the code. So we're declaring a value called sensor value. So this is going to be the value from this sensor. This at the moment is not really a sensor, it's just a variable resistor. And we are declaring pin A0 as input pin 13 using pin mode function as output. And again, we are creating the serial connection to the monitor, the serial monitor of the computer, serial.begin at 9600. So that's all the void setup routine. So in the void loop, we use the analog read function, and we read the value of A0 from, we read the value A0 and save that in the predefined variable, which is an integer, called sensor value. So then we map the sensor value we change it from 0 to 1023 and convert it from 0 to 500. So the minimum value should be 0 and the maximum value should be 500. This is obviously a linear mapping, so it will be the ratio, it will be scaled, linearly scaled, I mean not mapped, linearly scaled. So then what we will do is we will turn the digital output pin on, and then we will stop the program for the number of seconds, milliseconds, that that we have chosen with the variable resistance. So and we're going to output to the serial monitor the text on time is so many milliseconds. This is between double quotations. Now a \T gives me a tab in the serial monitor, and then in the next line, serial.println, we actually print out the value of sensor value, and then we delay the time for sensor value milliseconds. So now we turn the LED off and we digital write 13, so we turn the LED off, so pin 13 goes low, and then we stop the program for sensor value milliseconds. So its off time in milliseconds is also equal to sensor value, and we're delaying it for sensor value. So this is always going to be a square wave with a on-off time equal to 0.5 in this program, because the on time equals the off time. So if I take a look at this, I'm just going to let me do that. I'm going to hide the code. I'll minimize that. Not sure why the code's sticking out. So we're on, off, 210. If I make this smaller, sometimes the scope takes a little time to update. This isn't ideal. You'll get better readings on a real oscilloscope with real equipment. Just going to bring it to the middle. You can change the settings on this scope as well. I'm just going to stop that. So analog to digital conversion will be discussed in more detail in a later lecture. So the next one is reading analog pins and converting the input value to a voltage range. So transforming the input from one range to another is a common task. To do this, we use a conversion factor. A potentiometer that we use is just a voltage divider. In the circuit, we use it to adjust the voltage between the 5-volt pin on the Arduino and A0. The float data type is used for numbers with decimal points, but floats take up a lot of memory space, so use them only when precision is necessary.